All right, so let's get started. As Ian said, the idea in that presentation is to walk you through the projects that we actually have as part of the Eclipse IoT initiative. So I'm Benjamin Cabé, and I was working for Sierra Wireless until last week, and we were we worked with IBM and Eurotech to create that initiative and to contribute to some of the projects that were initially part of the initiative. And yeah, today I'm working at the Eclipse Foundation, and I'm going to talk about the project that we have. So first, you may have noticed that originally the event was supposed to be called the Eclipse M2M Day. So was our working group. The working group was the M2M working group. We recently renamed for IoT. Well, actually, for me, it's pretty much the same thing. We were even wondering if we would call the working group M2M/IoT, because you talk to some people, they will tell you that they do M2M because they do more gateway kind of things. But I think for a general audience, IoT is much more appropriate. Everybody knows what the internet is, and yeah, connecting things, pretty much everybody can know what it means. So what is it about? When we created the initiative more than 2 years ago, we had three open source projects for doing what Ian mentioned, tools, frameworks, protocols. We had kind of the initial contribution around MQTT, the MQTT protocol with the PAHO project. In terms of frameworks, originally this was the Mihini project, and in terms of tools, it was Koneki. So that was what we had at the beginning. PAHO, as Ian mentioned, is everything about MQTT. MQTT is a protocol for the Internet of Things. It sits on top of TCP. The idea is to have a publish-subscribe mechanism. All your sensors, your gateway, they will talk to a broker, send messages. Clients can be notified whenever a message is available. And PAHO provides reference implementations for MQTT in lots of languages, programming languages. You have Java, you have JavaScript, C, C++, Objective-C, Go, Lua, Python. And the MQTT ecosystem has been very successful for about 10 years now. And you have even other open source implementations that live outside of MQTT should you not find what you want in PAHO. Mihini, one of the three initial projects, is a framework on top of Linux for building gateways. It leverages the Lua programming language for helping people develop their gateways using kind of a scripting language. And so this was part of this initial contribution, and this is working closely together with Koneki. Koneki being a set of tools for building Lua applications, basically, and doing remote development and debugging on embedded systems and stuff like that. So that's what we had for like the first year or so of the initiative. But now we actually have 13 projects, and I will try to give you a quick overview of what these projects are. And as Ian said, and I think this is what you need to take away from that presentation today about the projects we have. These are really building blocks. We have protocol implementations, we have embedded frameworks, we have server-side technology, we have also kind of verticals solutions for building home automation solutions and stuff. But this is all building blocks that you can take and build your own solution on top of. So what are these 13 projects? So in no specific order, we have Eclipse SCADA. Eclipse SCADA being just like the name SCADA. It's basically system control and monitoring, equipment, industrial equipment inside factories and stuff like that. So this is based on OSGI, and you have a set of OSGI bundles plus plugins for your Eclipse IDE for monitoring industrial equipment and building, your own UI where you want to be able to see the level of a water tank and bind that very specific UI widget to a specific value of your industrial equipment. So that will be Eclipse SCADA. Then we have Cura, and Pierre from Eurotech and from the Cura project will talk about Cura at 4 this afternoon. Cura is pretty much like Mihini, but in Java and OSGI. This is a set of bundles for building M2M/IoT gateways. And when you use Cura, you have support built in for industrial protocols like CAN bus, Modbus. You can communicate with a cloud server using MQTT. So the code contribution for Cura should be available in the next couple of weeks, I think. But the project is now created, and yeah, the team is getting ready to contribute the code to the open source community. Then Ian mentioned briefly Mosquito. Mosquito is basically the server side of what PAHO would be. Mosquito is about the MQTT broker, what you run on the server to allow all your clients to communicate with each other. So it's written in C, so as it's scalable and can actually manage tens of thousands of connections at the same time. And it has also support for the protocol called MQTT SN. Or at least it's part of the scope of Mosquito to provide such an implementation. MQTT SN being MQTT on top of UDP to be even more lightweight and to cope with 6LoWPAN kind of networks and stuff like that. Then we have also server-side technology, also targeting MQTT, but not only. It's called Ponte. Ponte in Italian is bridge, and it's pretty much what is in the name, right? It's a bridge between different protocols that you may use for the Internet of Things. And initially, the Ponte supports MQTT CoAP and HTTP REST. The idea is that when you use a protocol like MQTT or CoAP, CoAP is basically HTTP REST on top of UDP. MQTT is basically topics and publish, subscribe kind of stuff. So this is something that bridges very well to the HTTP resources world. And Ponte is a technology written in Node.js that you would run on a server, and that will allow you to bridge MQTT topic namespaces to the HTTP world and vice versa. And so that's the code. The code is available. You can already npm install Ponte for those of you who are familiar with Node.js. Yeah, there's already a package available on npm, and that's a pretty cool technology. Then I mentioned verticals and ready-to-use basically solutions. So you may know about OpenHub. There are actually a couple talks today about OpenHub. OpenHub is joining the Eclipse Foundation as an open source project, and it's now called Eclipse Smart Home. And it's also written in Java and OSGI. And this is basically a set of bundles for building your own home automation gateway. Support for protocols like X10 and Bluetooth and all kind of protocols that you would have in your smart light bulb and stuff like that. Plus a rules engine, so as you can configure some rules, you want to receive an email whenever temperature reaches a specific threshold and stuff like that. So that's Eclipse Smart Home. Then Ian mentioned the standards that we are for which we have open source implementation. OM2M is one of them, and Thierry and Maddie this afternoon will talk about their project, which is basically an open source implementation of the ETSI M2M standard. And then still 4 projects to go. I know this is a long list, and hopefully you will go check out the project website if you want more information. For CoAP, we have Californium. The University of Zurich is working on an open source implementation of the CoAP protocol. So Californium is actually open source already, but it's in the process of becoming an official Eclipse project. it implements the latest version of CoAP, which is actually now officially a standard, even though I think there is some paperwork still to be done at the IETF. So it's written in Java. And the important thing is that it brings the support for GTLS, which is the way basically that CoAP addresses security. It's basically SSL for datagrams. Then we have also another standard implementation, which is Wakayama, brought by Intel and Sierra Wireless. This is a lightweight M2M implementation. So basically what lightweight M2M is, for those who are not familiar, it sits on top of CoAP, which means that it uses UDP or SMSs for the transport, and allows to do device management. It's basically OMADM without all the XML, blah, blah, blah kind of stuff. So as it's really bandwidth efficient, and you can do device management. You can do firmware upgrades and reboot your systems remotely and monitor battery level and stuff like that. Then we have Cricket. Cricket is pretty interesting in that if you talk to the people who actually build the IoT network, they start being scared because all these sensors that will eventually, because of IPv6 and because there will be lots of sensors that are directly connected to the internet, if they start being very chatty, then people who actually build the network, and the guys behind Cricket, this is Cisco, basically, so they know, I think they know what they talk about. They are scared that the network will just not be able to cope with sensors that report a temperature value every second and receive commands and stuff like that. So with Cricket, the idea is that you can configure the sensors, the edge of the network, so as there are rules as close as possible to the sensors, so as whenever a threshold is not reached, then the sensor will not report the value to the outside world and to the internet. So Cricket is basically a rules engine for edge devices, and I think it's going to be pretty interesting. The code is not yet available, but yeah, I think this is very, very promising. And 13th project is a Concierge, not necessarily the 100% IoT, but still very relevant for all the other projects that we have at the initiative. Concierge is a very lightweight implementation of the OSGI core specification. They also plan on implementing some compendium services of OSGI for those who are familiar. And yeah, the idea is basically with a couple of hundred of kilobytes of a jar file, you can run OSGI in an embedded constraint system. So that's Concierge. And yeah, maybe the 14th project will be yours. So if you have a cool idea or a project that you have that's open source already, maybe you may want to talk to me at the end of the session. So that's a pretty huge list of building blocks, right? So what is it you can do with these building blocks? As I said, maybe you would use smart home as is for building your own automation solution and monitoring your electric curtains and stuff like that. But more likely, you want to build your own infrastructure for monitoring whatever devices that you have on the field. So what can you build with our technology? Well, if you want to build sensor networks, then maybe what you will want to do is use run MQTT on your sensors. And as I said, if you use PAHO, you have pretty much every programming language you could think of for communicating with a server. So you will program your microcontrollers using the C very lightweight implementation of PAHO, or maybe you have some kind of gateway or more powerful devices for which you will run the Java MQTT implementation, and then you can use the Mosquito server on your own server, and you can build your own broker and start being able to have your sensors communicate with each other thanks to Mosquito. By the way, if you go to iot.eclipse.org, we run a Mosquito sandbox, an MQTT sandbox. So you go to iot.eclipse.org, there is a sandbox tab section in the website, and you have all the details of where this broker is actually hosted, and this is pretty convenient because when you want to start connecting sensors to the internet, it's very handy to have a broker that's already available on a public IP address and that's already running for you. So feel free to check out the sandbox that we have at iot.eclipse.org. So that would be one solution, but maybe all your sensors are not connected using MQTT. So in that case, maybe you may want to use Ponte as a broker. So Ponte can act as an MQTT broker. Maybe not as efficient, not as scalable yet as the Mosquito C implementation, but still, it will allow your MQTT to build your MQTT network. All your sensors will be able to talk with each other via the MQTT side of the Ponte broker. But you can also have another side of your Ponte broker that will be a co-op network. And so your sensor can actually be bridged back and forth between the MQTT world and the co-op world. So that would be one thing that you may be interested in using the technology for. Another solution. So I haven't built and made drawings for all the possible combinations of technologies. But if you want to do device management, maybe you want to use Cura plus an MQTT broker, or if you want to build something which is more along the lines of the lightweight M2M architecture, then you can run in your co-op network. You would use the Wakahama lightweight M2M implementation. Plus, there is already an open source server that's available on GitHub, and that's eventually going to be able, as part of Wakahama. If you go check out Leshan on GitHub, you will find it, and that way you can start building a device management infrastructure for being able to deploy new firmwares to your devices, monitor the battery level, and that kind of things. So yeah, as I mentioned earlier, you may want to build a home automation solution. So for that, it's pretty easy. You just download Smart Home. You have already a launcher for running Smart Home on your desktop if you want your main PC basically to be used as the Smart Home gateway, or you can run that on a BeagleBone, a Raspberry Pi. And so the idea is that you can use the Smart Home will have support for several protocols, and the list is actually, I think it's like 50 protocols that are supported. So you have what Smart Home called bindings. So you can define bindings between sensors and some values that you want to manage in your system. And for these values, you can define rules. According to these rules, you will be able to build a UI, for example, and that UI you will be able to have it on your Android smartphone or on the web UI. And you can also actually use the MQTT binding. So if you have some sensors that are maybe using MQTT to talk with each other, you can also use the MQTT binding to connect to an MQTT broker and retrieve some of the values via the MQTT binding and start building rules. If this MQTT sensor is above 20 degrees, then I want to send command number 42 to my extend switch, etc., etc. So yeah, that's a few samples of what you may want to build with the technology. So you may wonder what is next. Ian mentioned some of the things that we would like to address and we would like the project to allow to build. One of them is big data. I mean, we have some technology at Eclipse already for doing reporting kind of stuff. Like I don't know if you know BERT. It's basically a reporting tool for doing business intelligence. So I think one of the next thing is trying to make use of all the data that all the sensors will send. And This is going to be important to have open source technologies as well as open source standards, so as this data is actually meaningful and can be consolidated and displayed on charts and stuff like that. Security is also important. So we are fortunate enough to have Co-op and Lightweight M2M that joined recently. But I think it's really important to start addressing the security in the IoT communications. It's quite a tricky problem, as you may know, because we talk about very constrained embedded systems. So yeah, you don't want to have like 5 or 6 round trips back and forth with the between the embedded device and the server to negotiate an SSL handshake and stuff like that. So it's important to have open implementations of security stacks, and yeah, Californium, Lightweight M2M, even MQTT actually is also working on its security story. And last but not least, and this is where I think some people in the room may have ideas and possible contributions. This is everything regarding interop and especially data semantics. When you use things like MQTT, Co-op, even HTTP, well, you have the communication channel, but there's not yet strong standards and a strong consensus about what and how the payload should actually look like. I mean, people who do HTTP, they will very likely use JSON kind of packets or XML. People who use MQTT or Co-op, since they have ways to structure the data using resources or topics, then part of the semantics of the information will be in the topic itself or in the path of the resource, and some of the semantic will be in the actual payload. And again, it's going to be JSON, it's going to be some kind of binary format to optimize the payload, but we still lack yeah, initiatives around interoperability, and I mean, we have Ponte. We start being able to bridge some of the networks with each other, but not at the semantics level. It's more about the transport for now, unfortunately. So I think I'm pretty much done. I wanted just to highlight a few of the IoT events that are coming, and after that we will have time for questions. And I'm sure you have, because I mean 13 projects. I'm sure you have questions. EclipseCon, you still have time to register and to think about joining us in California mid-March next month, especially since we have an IoT day. So we will have people from all over the world actually talking about open source and IoT. We also have great content around the MQTT. If you want to learn more about MQTT, we will have a tutorial. And I mean, in general, EclipseCon is really a great conference to meet with the community who actually work on all these open source projects. Then we have. So unfortunately, yeah, for EclipseCon, you don't. I mean, it's over for submitting possible talks and posters and papers. But we have 2 other conferences for which, plus Eclipse Conference, of course, we have IoT Live on April 9th. There will be an IoT World Day, basically, and what we decided together with the online website Postscapes is to organize a virtual conference. So we will have all day long a virtual conference, a Google Hangout, basically. And so if you have ideas of talks around IoT and big data, IoT and open hardware, IoT for building and for bridging with the industrial networks and stuff like that, it would be great for you to check out the website and to possibly submit a talk. And then that time in Europe, at the end of May, there is an Eclipse Day in Florence, not that far from here, I think. And the topic this year is embedded M2M and IoT. So this is also something you may want to check out and for which you may want to submit a talk. And I think that's it. So if you want to learn more about the projects, you can ask questions like right now, or you can check out the iot.eclipse.org website. You will have links to all the projects, as well as I said, well, somewhere here, if you scroll on the page, you will have the sandbox section, and I mentioned earlier. So yeah, that would be iot.eclipse.org, and now I think we have plenty of time for questions. And you can ask the questions in French, if that helps. No questions? Yep.
So again, I am Daniel Kaufman from Telecom Tech. I know nothing about open source, but I'm working on these topics, and I think that we will need to integrate many of these components, much more than what you highlighted in the use cases. My question is about how easy it is to integrate those components, which type of APIs you're proposing. They are written in different languages, as I understand. Can you say the word of how easy it is to transform these components into a solution?
Well, most of these components, the good thing is that the people and the companies who contributed the projects, they actually use the components for building their own solutions. So usually these components, they come with documentation. They are meant to be integrated in bigger solutions. So basically, if you think about something like the Mosquito broker, it's really meant to be built. All the instructions for building the broker and for installing it on your own server, it's part of the of what comes with the open source project. For some of them, they are more maybe experimental. So you may want to talk to the guys behind the project. But usually, what we try to have for all the projects is good documentations, tutorials. All these people running the projects, they, as Ian highlighted earlier, they usually attend conferences where they talk about their projects. So you will find material online like slides and wiki pages and documentation, and you have mailing lists for getting in touch with the project. So that's usually, you start experimenting yourself, and if you get stuck at some point, you can easily reach out.
There is not a kind of coordination to facilitate the integration. No? There is not a
not yet.
What we used to call middleware to facilitate this type of things.
Well, some of the technologies, they are kind of middleware already, like the embedded frameworks and
want
stuff.
to facilitate the integration.
Yeah. No.
Okay. The second issue is just a remark. We launched 4 years ago a project with Alcatel Lucent, what you call interop, about the usage of semantics to facilitate the interworking. This is just a remark. If you have time, I'll be glad to discuss.
Yeah, sure. That would be great. Thanks. Are there other questions? So I think this is the coffee break right now. And thanks for your attention.